Hello, everybody. So we're going to start the final module of the sixth grade Go Math textbook. And in this unit, we're going to be looking at the concept of statistics and data sets. And our first lesson is covering the concept of measures of center and how does that describe a data set. So let's look at this first activity, finding the mean. Okay, in math, a mean is simply another word for average. So a measure of center is a single number used to describe a set of numeric data. A measure of center describes a typical value from the data set. And so average, that would be a good measure of center because it's all the numbers added together and divided by the number of sets. And that's going to give you the average number. Some will be higher, some will be lower, but most of them will be right around the average of the data. So one measure of center is the mean. The mean, or average, of a data set is the sum of the data values divided by the number of data values in the set. So here's an example. Tammy surveyed 5 of her friends to find out how many brothers and sisters they have. Her results are shown in the table. So these are the 5 people she talked to. And Amy has 2 siblings, Ben has 3, Cal has 1, Don has 1, and Ava has 3. So we can use counters to represent that. So we see that Amy has 2 counters, Ben 3, so on, right? Okay, now to find the average though, basically the ones that have the greatest total, they would lose one of theirs so that everything evens out. And that's the concept of the average, is that you take kind of your high values, your low values, and it's going to give you something that's in the middle. So here we see that they have 3. If I took this one and moved it to Cal, he would have 2. If I took the one from Ava and moved it to Don, he would have 2. And then everybody else would also have 2. So by rearranging them, we see that each group now has 2 counters. And this value is the mean. So that's the concept of evening out the data values. But we can use mathematical operations to do this as well. So in this case, what are the different numbers in the data set? Well, we know that there's 2 and 3, and then we have 2 ones, and our last one we had 3. So you would add up the value of all the data values. 3 and 2, 5, 6, 7, and 3 more is 10. So the sum of all the data values is 10. Now, how many data values are there? Well, there's 1, 2, 3, 4, 5. 5 pieces of data. Okay. And that leads to a division problem where we find the mean by taking the sum of the data values, 10, and divide by the number of data values in the set, 5 in this case. And 10 divided by 5 is 2. So can the mean be greater than the greatest value in a data set? Think about it. Could our average of those siblings be greater than 3? No, because the group with the greatest number, they lost counters, right? So that things evened out. So no, it's not possible to have an average greater than the greatest value. Okay, so no, if we're using like the concept of the counters, the one that had 2 of the groups had 3. Some of them had 1, some had 2. Well, we have to take some of the counters from the largest value groups to give them to the other groups so it evens out. We're finding an average. But there's no way for an average to be greater than the greatest value. We're not adding to that greatest number. We're actually evening them out by taking it away. Right. Now, another measure of central tendency is called the median. And the median represents the middle value of an ordered data set. That word is very key in median, ordered. So we have to put them in increasing order or decreasing order. It really doesn't matter which one because the middle value is still going to be the middle, whether you put them in order from least to greatest or greatest to least, because you have the same numbers. So in this table over here, we have 3 miles, 5 miles, 7 miles, so on, okay? And so they put them all in order from 3, 4, 5, 5. You notice that the 5 is repeated. You have to put the same number of values that you've collected. So in this case, we have 2 that were 5 miles, so I have to put both. And we have a 6, and then they see 2 7s. Well, because there's 2 7s in the table or in the data. And then there's also 3 10s. Okay, 1, 2, 3 10s. Now I like to make sure that I have all my values accounted for, so I'm just going to double check by counting them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I should have 11 pieces of data here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I have the right numbers. They are in order. And so basically, you kind of cross off from each end and work your way towards the middle. So you notice that I've crossed off 4. Oops, sorry about that. 10, 3, 10, 4, 10, 5, 8, 5, 7, 6. Okay, so I crossed off 5 from each end, and that left 7 in the middle. So 7 is the median. Now, if we happen to have 2 numbers in the middle, we're going to have to add those 2 together and divide by 2. So when we have an even number of data points, like let's say if we had one more here, we'd have 12. Well, you couldn't get down to like say 7 and I don't know, let's say 2 7s. In that case, we'd add the 2 7s together and divide by 2. They give us 7. All right. So find the median of these test scores. And so again, they have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. Well, now we have an even number. So when we put them in order and we cross off from the ends and work our way towards the middle, I have 2 values left. Well, I can't cross those out because then I have no middle number. So what I do in this case is I take those 2, add them together, divide by 2. So 87 plus 90 is 177, and 177 divided by 2 is 88 and a half. Okay, so we're basically going to be practicing median and mean in this lesson. All right, so let's look at number 2. Which units are used for the data in A? Well, in A, I notice that it says 3 miles, 5 miles, 7 miles, 10 miles, so on. So they're using miles. And they want to know if the coach had recorded some distances in kilometers and some in miles, can you still find the median? No, when we deal with median, we have to be using the same units. So you either have to convert everything to kilometers or everything to miles. So no. Okay. All right, number 3. Charlotte recorded the number of minutes she spent exercising in the past 10 days. 12, 4, 5, 6, 7, 8, 7, 9, 8, 2, 1 minutes. So find the median of the data. All right, so we're going to put these in order from least to greatest. So looking at this, it looks like 1 is the smallest, and there's only one 1. Okay, there is a 2, and there's only one 2. 4, and there's only one 4. 5, only one 5. 6, one 6. 7, there's one 7. There are 2 8s. There's a 9 and there's a 12. So 2, 4, 6, 8, 10 pieces of data. 2, 4, 6, 8, 10. Yes. So we have all the right numbers. And so we're going to work our way to the middle. So cross off that one, cross off that one. Cross off this one, cross off that one. Cross off this one, cross off that one. Cross off this one, cross off this one. Now we notice that I only have 2 values left, and I can't eliminate them, so I'm going to go 6 plus 7, divide by 2. So 13 divide by 2. 6.5. So 6.5 is the median. All right, so in our next activity, we're going to start looking at which one actually represents the data set the best. Is it the mean or the median? Now, sometimes the mean is affected by a really low value or a really large value. And so we'll look at those. And sometimes the median winds up being the best measure of central tendency because when you're moving towards the middle, you're eliminating those extremes on the outside, the largest values and the smallest values. So when you get to the middle value in the median, you usually have what is most representative of all the data points. All right, so the mean and median of a data set may be equal, very close to each other, or very different from each other. For data sets where the mean and the median differ greatly, one likely describes the data set better than the other. And that's what we're going to be practicing right here. So the monthly earnings of several teenagers are 200, 320, 275, 250, 750, 350, 310. Well, just looking at this, the 750 seems really out of line with all the other numbers, right? So just keep looking at that, it looks to me like the average is going to be higher than what is typical of the other teenagers. So I'd probably want to use the median in this case, but let's check it out. So we're going to write the values: 200, 320, 275, 250, 750, 350, and 310. Okay. And it says find the mean and round to the nearest tenth. So we have to add all those values up. Now, sometimes I think it's easier to combine 2 numbers and make them smaller so we have less numbers to be adding. So 200 plus 320, that's 520. 275 plus 250, that's 525. 750 plus 350 is 1100. And then we have our last number, 310. So now we have 520, 525, 1100, and 310. Okay, so 5, 5, 14, 2. So we get 2,455. And we need to divide that by how many? 1, 2, 3, 4, 5, 6, 7. There's 7 pieces of data. So 2,455 divided by 7. All right, so basically we wind up with 350.71, and it says round to the nearest tenth. So we're going to say it's about $350. It would be 70 cents, but $350 and 7/10. Write the data values in order from least to greatest and find the median. All right, so our smallest value is 200. Our largest value is 750. So 200, 250, 275, 310, 320, 350, 750, 2, 4, 6, 7. Okay, so we have the same numbers. So we're going to work our way towards the middle by crossing out one from each side. And I'm only left with one in the middle, so 310. So the mean and the median differ by about 40, 41, 40 to $41. Why? Why is there such a big difference between those two values? Well, it has to be the 750. Okay, when you look at 350, right? Well, 200, that's kind of low, right? 320, that's right around there. 275, okay. 250s, all right. But when we look at 310, that's actually real close to most of the numbers, right? Or closer. So the value the value 750 increased the mean. So in this case, I would use the median. Okay. So it's more representative of the values in the data set. When I look at 350, there's only really two numbers that are 350. Actually, one number that's 350. So there's only one that's close to 350. When we look at 310, 320 is close to it, 350 is close to it, 275 is closer. So there's more values that are close to the median than there are to the mean. All right, let's look at 454. Number 4. Luca's final exam scores for this semester are 70, 72, 99, 72, and 69. Find the mean and median, which is a better description of Luca's typical exam score. Explain your thinking. I'm looking at this 99 in his test scores, and that's kind of not representative of the other 4 tests. So I just by looking at that, I think the median is going to be better representation. But let's solve this. So the mean. How do we find the mean? We add up all the numbers in the data set. So we have a 70, a 72, a 99, 72, and a 69. And there's 1, 2, 3, 4, 5 pieces of data. All right. So I'm going to combine two add-ins to make it a little easier to add. Okay, so we have 142, 171, and 69. I get a sum of 382. And I'm going to have to divide that total by 5 to find the mean. Remember, the mean is just another word for average. So we come up with a mean of 76.4. That's close to that, close to that. Oh, not close to that. 72, 69. So mean 76 and 4/10. The median. Median, just put the numbers in order from least to greatest. Okay, so the 99, that increased the mean, right? But when we talk about the median, that gets eliminated as we work our way towards the middle. So there's 5 pieces of data, so the 70 and the 72, that just leaves me 72. So the median is 72. Which one's a better representation? Well, there are 2 values that are 72. 70 is only 2 away, and 69 is only 3 away from 72. So I think that's more representative of his test scores, 72. All right, guided practice, number 1. So Spencer surveyed 5 of his friends to find out how many pets they have. His results are shown in the table. What is the mean number of pets? So we have 3 plus 5, that's 8. 2 plus 4 is 6, plus 1. So if we add those together, we get 15. So the sum of the data points is 15. There were 5 pieces of data. 15 divided by 5 is 3. So the mean is 3, meaning the average number of pets that each of his friends has is 3. Now the following are the weights in pounds of some dogs at a kennel: 36, 45, 29, 39, 51, 49. We need to find the median. So median, we need to put the numbers in order. 29, 36, 39, 45, 49, 51. So 1, 2, 3, 4, 5, 6. Okay, so there's 6 pieces of data. That means I'm going to have 2 numbers in the middle. So I work my way towards the middle by crossing out the one from each end, and we're left with 39 and 45. So 39 plus 45 divided by 2. 84 divided by 2. 42. 42 pounds is the median. Suppose one of the weights were given in kilograms. Can you still find the median? No. Nope. They all have to have the same units first. Find the median of this data set. All right, so we have 9 plus 6 plus 5 plus 3 plus 28 plus 6 plus 4 plus 7. And we need to divide by 8. Okay, because there's 8 pieces of data. So 15 plus 8 plus 34 plus 11. $68 divided by 8. Eight and a half. So the mean of our data set is 8.5. The median. So put the numbers in order. 3, 4, 5, 6, 7, 9, 28, 4, 6, 8. Work our way towards the middle by crossing off 1 from each end. And we notice that we have 2 in the middle, but they're both 6, so there's no reason to have to add that together. It's the median 6. Okay. All right, in 3C. So which one better describes the set of data? I would say the median, because most of the values are right around 6. 8.5, that's really actually too high. There's only one value, 2 values that are around 8.5. Okay. The 28 increased or inflated the mean. So I would use the median. All right, so how can you use measures of center to describe a data set? Well, what are we doing when we get that? Well, we're basically trying to describe like the average of the data set or the middle value of the data set. So the mean will give the average of the data set. And the median so basically measures of central tendency or measures of center, sorry, is kind of a way of summarizing the data set. And the two that we've learned so far is the average of the data set and the value of the middle of the data set. All right. So let's do some independent practice. So several students in Ashton's class were randomly selected and asked how many text messages they sent yesterday. Their answers were 1, 0, 10, 7, 13, 2, 9, 15, 0, 3. How many students were asked? 2, 4, 6, 8, 10. How do you know? There are 10 values. Find the mean and the median for these data. All right. So we have 1 plus 0 plus 10 plus 7, 13 plus 2 plus 9 plus 15 plus 0 plus 3. And we need to divide that all by 10. All right, so 10 plus 1, that's 11. 7 plus 13 plus 2 is 22. 9 plus 15 plus 2 is 26. And plus 3. So we have 29 plus 22 plus 11. Okay, all I did was combine 26 and 3 to get 29. And then I'm using 22 and 11. So we get 62. 62 divided by 10. Well, that's 6.2, right? Oh, no, I am incorrect. I added 2 twice. Okay, so 1 plus 10 is 11. 7, 13, 2 was 22. But this next set should have been 9 plus 15. 24 plus 0 is 24 plus 3 more is 27. So it's actually 60. All right. 60 divided by 10. That's just 6. What's the median? Well, put the numbers in order. 2 zeros. A 1, a 2, a 3. 7, 9, 13, 15. I'm missing one number. 0, 0, 1, 2, 3, 7, 9. I left off 10. All right. So work our way towards the middle. Cross off 15 and the 0. Cross off 13 and the 0. Cross off 10 and the 1. Cross off 9 and the 2. And we're left with 3 plus 7. So the median is 5. All right, 7. Find the mean score and the median score. I gotta leave myself enough room. Sorry, guys. So the mean 73, 77, 85, 84, 37, 115. And there's 6 data points. Okay. So 73 and 77 is 150. 85 and 84 is 169. And 37 and 115 is 152. So we have 471 divided by 6. So we should get a mean of 78 and a half. And our median, well, let's just put the numbers in order. So we have 37, 73, 77, 84, 85, 115. Work your way towards the middle. We have 2 values in the middle, 77 and 84. 161. 80 and a half. Now, those two, they're really close together, right? There's not a significant difference. The reason the mean is similar to the median in this case is because we had one really low score and one really high score. So in a sense, they kind of canceled each other out. So the rest, these would basically be our numbers that are our average. And so 78 and a half is reasonable, and so is 80. We have two values in the 70s. We have two values in the 80s. So I would say both. So both are representative of the data. Most of the values are close to the mean and the median. All right, number 9. So we have minutes and hours in this table, and it says what units are used for the data. What should you do before finding the mean and median number of minutes? Okay, so if we have to find the mean number of minutes, we need to convert hours to minutes. Okay, so this half hour, I'm going to change to 30 minutes, and the hour, I'm going to change to 60 minutes. All right, so now let's find the mean. So we have 16 plus 7 plus 14. 6 plus 7 plus 14 plus 30 plus 5 plus 8 plus 12 plus 60. And we need to divide that by 8. Okay, there's 8 sets of data points. So 16 and 7 is 23. 14 and 30 is 44. 5 and 8 is 13. And 12 and 60 is 72. $152 divide by 8. 19. So you get an average of 19 minutes for the mean. All right, find the median by putting the number of minutes in order. And work your way towards the middle. Since it's an even set of data points, you're going to have 2 in the middle that we'll have to add together and divide by 2. Okay, so we have 12 and 14 in the middle. 13 is the median. Which measure do you think is more typical of the data? Well, we do have a couple that kind of inflate the mean, right? The 30 minutes and the 60 minutes. The 60 minutes really inflates it. So I would suggest using the median in this case, because by using the median, you eliminate those 2 really high numbers as well as the 2 really low numbers. So most of the data is kind of about, well, it's about 13. Yeah. So okay, so the median, the 30 and the 60 minutes increases the mean, and the other values are closer to the median. All right, number 12. All right, so for 2 weeks, the school librarian recorded the number of library books returned each morning. The data are shown in the dot plot. The librarian found the mean number of books returned each morning. So she's adding up all the numbers and dividing by 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. No, she should be dividing by 10. There's 10 dots here. She didn't add the 2 zeros. So while the zeros don't change the sum, they are part of the data set. So we have to divide by 10, not 8. All right, 13. Lauren scores on her math test 93, 91, 98, 100, 95, 92, 96. What score could Lauren get on her next math test so that the mean and median remain the same? Okay, so let's see. 93, 91, 98, 100, 95, 92, 96. We need to divide that by 7. Right, 93 and 91, that's 184, 198, 187, and then 96. Okay, so her average, her mean is 95. The median, her lowest score was 91, 93, no, 92, 93, 95, 96, 98, and 100. Work our way towards the middle. 95. The median is 95. Okay, so what score could Lauren get on her next math test so that the mean and median remain the same? Well, if the average is 95, and we added another 95 to the data set, right? So we're saying that if we say that she gets another 95 on this next test, and we work our way towards the middle, she'd have 2 95s in the middle. So she needs to get a 95. Okay, if she scores 95, that's not going to change the average any, right? 95 is 95, so she hit the average. And the median, there would be 2 95s in the middle, so they would stay the same. All right, 14. Yuko wants to take a job selling cars. Since she'll get a commission for every car she sells, she finds out the sales price of the last 4 cars sold at each company. Okay, so we have company A, company B, and we need to find the mean selling price at each company. So let's go company A. And I'm just going to add, think of this as 16,000, 20,000, 25,000, and 35,000. Okay. So 30, and we're going to divide by 4. 36 plus 60. So we have 96,000 divided by 4. So we're going to have 24,000. So company A $24,000. Company B, $21,000, $23,000, $36,000, $48,000. And we're going to divide by 4. All right. 21 and 23 is 44. Again, these are in thousands, so 44,000. And 36 and 48 is 84,000 for a total of 128,000 divided by 4. So 128 divided by 4 is 32,000. All right, find the median selling price of each company. All right, so again, I'm not going to put the thousands on there just for sake of saving space. Oh, actually, I don't need to put these in order. They're already in order. So cross off from the ends, and we have 45,000 left in the middle. So 45 divided by 2. So 22,500 is the median for company A. In company B, we have 23,000 plus 36,000, 59,000 divided by 2. $29,500. And these are in dollars, right? All right. So at either company, Yuko will get paid a commission of 20%. So that doesn't change. That doesn't matter. So the more money that the company average on selling cars and the middle price means she's going to get more money. Well, company B has a higher mean, and they also have a higher median value. So she should definitely work at company B. All right, since the mean on the car sales at company B is higher than at company A, and the fact that the median is also a higher value than company A, if you're getting paid on commission, you'd rather have 20% of the two larger values, right? So company B would be the best company for her to try to work at. All right, so that's it for our first lesson in measures of center. So until our next lesson, I will see you soon.